Okay, so I'm showing you how to do the analyses for today's lab 9, which involves calculating alpha amplitude for two different participants for two different conditions. One of the condition, the participant's eyes are open, and then for the other condition, the participant's eyes are closed, and we will be comparing we'll be calculating alpha amplitude for these two conditions. It turns out we weren't able to actually collect data from actual participants. I just used myself and I did it twice. So I'm both participants for this study. We will not actually be performing statistical analyses because the sample size is too small. It's just me twice. But we will be making calculations of alpha amplitude using software Biopac for both of those participants. And then we will be, writing them into a Google Doc. So I'll show you how to do all of that stuff here in this recording. First, though, let me go to the slides. Let's see. So these slides that I'm looking at right here, these are available on Blackboard in the labs folder. It's one of the ones for lab 9. And so this lab is it's all based on a video I showed you in class. I believe it was Wednesday. It was a recording of myself being the participant, and you actually saw the data being collected live. You saw the data being collected in that video as it was happening. And we will be analyzing that data file and one more that I recorded previously. And so for each data file, there will be 4 trials. So the way each trial works is at the beginning, my eyes are closed, but for the first couple seconds, we're not going to count that as a trial. Then Alex, my assistant, says, open your eyes, and I open my eyes. That's trial 1. And she pushes a marker at the same time that appears, and I'll highlight that here in a second when I show you that video. That marker indicates the beginning of the eyes open trial. And then she says eyes closed while also pushing a button, which causes a marker to appear. And that's the beginning of the eyes closed trial, which lasts 5 seconds or so. Then she says eyes open again and pushes a button, which sends a marker onto the computer. That's the beginning of the eyes open trial. And then finally, the 4th trial, she says eyes closed and pushes a button on the keyboard, which sends a marker onto the computer. That's the beginning of the 4th trial, which is eyes closed. So we're going to have 4 total trials. 2 of them are eyes open. 2 of them are eyes closed. You are going to be calculating for both participants, both participants or me, but for both data files, you will be calculating alpha amplitude for all 4 trials. And then you will then be copying and pasting that data, you'll just be typing it rather into an Excel sheet. That Excel sheet you're going to type the amplitudes for those 4 trials into the Excel sheet. And then the Excel sheet should calculate the means of the 2 conditions automatically by taking the mean of the 2 open eye trials and then the mean of the 2 closed eyes trials. It should calculate those means without you having to do anything. All you have to do is type in the correct amplitudes, and then the means for the 2 conditions for each participant should be calculated for you. And then you will be copying and pasting those means into a Google sheet, and we will talk about them a little bit in class next week. So let me go ahead and show you this video right here. I showed you this in class, but I'm going to just show it to you again because it's definitely important that this lab is based on this video.
Okay, so Biopac is going.
So I want to remind you, the trace that you see, and you can even see it says EEG right there. I have 1 electrode measuring my activity. It's over here over my occipital lobe in the back of my head. And what you're seeing here, this is just the raw EEG signal. So it's the electrical activity. Presumably most of that activity is coming from my brain. And this is before any Fourier analysis has been performed on this. This is just a complex EEG waveform, the raw EEG waveform. We have not performed any sinusoid. We have not performed a Fourier analysis yet. So the different sinusoidal frequencies, the alpha band, the delta band, the beta band, the theta band, those have not been calculated yet. Those occur after data collection occurs, and I press a button on Biopac, which is the software that does all this, and then the Fourier analysis is performed. So we'll continue on. please notice my eyes are closed, but this stuff at the beginning doesn't count as a trial. This is just like the beginning of the experiment when we're not counting this. And then Alex says eyes open, and that's the beginning of the first trial.
Eyes open.
Please note the marker that appeared when she said eyes open.
Eyes closed.
The marker appeared when she said eyes closed.
Eyes open.
Marker for eyes open.
Eyes closed.
And the marker that appeared for eyes closed again.
Eyes open. You're done.
And this marker just means we're done, and we don't care about any of the stuff past here. So I just paused it real quick. So I just want to point out the 4 trials. This is the first eyes open trial, the first eyes closed trial. This is the second eyes open trial, and this is the second eyes closed trial. The stuff at the end we ignore, and the stuff at the beginning we will ignore. So trial 1, trial 2, trial 3, trial 4. You will be calculating the amplitude for each of those 4 trials, but you will not be calculating the amplitude based on the raw EEG signal. You will be doing it based on the alpha amplitude. In order to get alpha amplitude, Biopac will have to perform the Fourier transform, which happens very easy. I just press yes right there, and it will perform the Fourier analysis automatically.
Eyes open, eyes closed, eyes open, eyes closed. It's always that one that's the biggest.
So I was just talking to Alex there in the video. I was just talking to Alex, kind of just noticing things. We were running this and just wanted to make sure that it would be good for this exact lab, that the data would work well for this lab, and they do, so we're using it. I just want to point out, so shown here, and I'll show you this exact data file here in a second. I'll open it up on Biopac, and I'll actually show you how to analyze or how to get the amplitude measurements for each condition. I just want to point out right here, this green trace, channel 40, this is the alpha amplitude. Right here, channel 41 beta, channel 42 delta, channel 43 is theta. Right now, channel 1, which just shows the raw EEG signal, that's hidden, and I'll show you how to show that in a second when I open up Biopac. So you can see the raw EEG trace if you want that was just recorded on the screen. So yeah, once again, we'll be calculating alpha for this trial, alpha for this trial, alpha amplitude for this trial, alpha amplitude for this trial, and you will be typing those numbers into an Excel spreadsheet. So now I will open up Biopac. So you will have to download Biopac. To download Biopac, it's a free software. So you're not downloading the entire Biopac, you're downloading in particular the free analysis software. And I've provided a link. It's in the announcements on Blackboard. Link to download Biopac BSL Analysis 4.1. So you copy and paste that link into your browser. You're going to find a section called Current Release. And in there, there'll be 2 links. One is BSL Analysis 4.1 for Windows or PC. And then there's also a BSL Analysis 4.1 for Mac. And they work very similar, slightly different, buttons for shortcuts and stuff, but they're very, very similar, and they look almost identical on the screen. So that will take probably you guys 5 to 10 minutes to download and then install that free software. I will point out that you guys can do this in groups, so not every single person will have to download this software if you work in groups. Though if every single person in the class wants to do this by themselves, by his or herself, that would work too. But if you want to do it in groups, that would make it so not everyone would have to download the software, though it is free and it is, cool software. Okay, so now I've already downloaded, so I'm not going to show you how to do that. But you can also, I will open it up here in a second. You also will need to download the 2 data files for this lab. The 2 data files they're linked right here. Copy and paste them into your browser and then download them. And then I would suggest moving them somewhere convenient, like your desktop or to your documents folder. Right now, I still have mine in my downloads folder, but I know how to find them pretty easily in there. Download each of those. And then now I will show you how to open up those data files using Biopac. So I'll point out, if you just for me, at least in my computer, once I download those files, if I just double click on them, they're basically just text files. And so if I double click on them, just when I download them, it just is a bunch of random letters and numbers, which make no sense. It's just a text file. in order to open it in a way that you can actually see the data and analyze the data, you first have to open up Biopac, the BSL analysis 4.1, and then you use that to open up the data files that you just downloaded, the text files that you just downloaded. So now I will go ahead and show you how to open up Biopac. For me, I just have to go to my applications, BSL analysis 4.1. This is what I've been referring to as Biopac, but it's really called BSL analysis 4.1. The company that makes it is Biopac. Click on the folder for me, and then this green icon right here, BSL analysis 4.1. Double click. And you want it to look something like this. Analyze your own data should be highlighted because that's what we're going to be doing. We're going to be analyzing data files that I made. And then also you want open a lesson data file for analysis. So those are the two things that you want to be like checked. Analyze your own data file and open a lesson data file for analysis. So those are correct for me. So I'm going to press OK. And then for me in my computer, it goes directly to like my directory here. So I just need to find the files. For me, they're in my downloads. This first one that I want, this one I believe starts with the word alpha. So I'll find alpha here. I know I have lots of files in my downloads. There it is right there. Everything else is kind of grayed out except for this. And it says as a text document, but when you use Biopac to open it up, it will not open up as a text document. There it is. So that's not exactly what yours will look like when you open it up. So yours will probably look something like that when you open it up. So it'll show the alpha channel is channel 40, channel 41 is beta, channel 42 is delta, channel 43 is theta. These are the exact data that you just saw on the video that I just showed. Please note that right here, that 1 is crossed out. That 1 shows channel 1, which is where the raw EEG, the complex EEG waveform is, the signal before the Fourier analysis was performed. If you want to see that on Mac, you press Option and then click on the 1, and then you can see that's when the data was being collected, you know, in the video, you could see that trace moving up and down. This is the exact trace that was being recorded there in that video. So for Mac, you press Option and then you click on that and it will open, or it'll either appear or disappear the channel that you want. For PC, I believe you press Alt and then you press the number right there. It's definitely one of those buttons to the left of your space bar. You press the button and then you click on up here, and then you can make these different channels appear and disappear as you want. So there's none. Really the ones that I guess we care about, really the only one that we really care about is alpha. That's the only one that you're actually going to be calculating anything for. But I kind of like having the raw EEG waveform open at the same time for some reason, but you don't have to. Really, so you can have these two open, or really you can just have just the alpha channel 40 open. That's really all you need. But I'll keep both channel 1 and channel 40 open. And so in order to calculate the amplitudes, you need to use these boxes up here. And you should have them, they'll be set differently for you. So you need to adjust them, something like this. Really, all you really need is for one of them to say channel 40 and standard deviation. I'm going to do it a little bit differently. I'm just going to have this one say channel 1 standard deviation. And then this one will say, so you can click on this and then you can choose the channel. Click on channel 1, click on this. These are a bunch of different calculations which can be performed, but we want to leave it on standard deviation because standard deviation is the way that amplitude is calculated, at least in Biopac. You just calculate the standard deviation of the waveform for a highlighted portion, and that basically calculates amplitude. So channel 1, standard deviation, which is amplitude, will show up here once we've highlighted something. And then channel 4, this is the alpha. This is the one we really care about, standard deviation. And then that standard deviation or the amplitude will appear right here once we've highlighted sections of the waves. Just to avoid confusion, because we don't really care about channels 41, 42, 43, I just changed all of these numbers to 40 and standard deviation, 40 and standard deviation, 40. Oh, that one says frequency. Where's standard deviation? Oh, there it is. Yep, there we go. So these, when I will highlight something, these will all show the same number in these boxes right here. They'll all show the standard deviation, that is the amplitude for channel 40. They'll all show the same number. And I have them all set at 40 just because that's really the only channel we care about for this is channel 40. So let's go ahead and do it. So once again, the stuff at the beginning, this was, my eyes were closed, but that's like the portion where we're just kind of starting up the experiment. So we're not going to count that as a trial. The first trial occurs right here with this first marker that occurs after the 0 time point. This was when Alex said eyes open. So you highlight the entire trial as well as you can. It's hard to be perfect, so it doesn't have to be perfect, but as good as you can. Highlight the whole thing. And then right here, this is the amplitude for channel 1, 6.974, etc. We don't actually care about that, but that is the amplitude, which is right here. What we care about is the amplitude, which is right here, because this is the alpha. This is the Fourier analyzed sinusoidal waveform. This is the alpha portion. Channel 40 is alpha. So channel 40 standard deviation, which is how we calculate amplitude, shows for that trial. So this is an eyes opened trial. The amplitude is 3.5718. Right there, 3.5718. And so you would take that number, that's the alpha amplitude for the first trial, which was eyes open, is 3.571. We'll round it to 3.572. And then we'll go to the Excel spreadsheet. So this is available on Blackboard as well. There's a small set of PowerPoint slides, but this Excel sheet is there too. It should look just like this when you download it. And the participant we're working on right now, this is the Alpha EEG Rosenthal Demo 4. So this is the bottom one. The eyes open amplitude, that's the first trial. As I said, there's 4 trials. We just did the first one. The value is 3.572. 3.572. You write it right there. And then we'll do the same thing for all these others. So let's do it again. So now we're at the eyes closed trial, the first eyes closed trial. Once again, we don't care really what's going on in channel 1. All we care about is channel 40, which is where alpha is. So for the eyes closed, that was 4.275. Eyes open again for this next trial. 3.447, it looks like. 3.447, and then eyes closed is the last one. 5.329. Please note that Excel calculates the means of the two. There's 4 trials, but there's only 2 conditions because it repeats eyes open and then eyes open again, eyes closed and eyes closed again. Excel takes the means of C4 and E4. That's the mean of the eyes open condition. It takes the mean of D4 and F4. That's the mean of the eyes closed condition. It shows them right there. These will be the means that you eventually will copy and paste into the Google Sheet. I want to show you, so that's how to measure alpha amplitude for each of the 4 trials. The Excel sheet will calculate the means for you. I do want to show you the other data file real quick, even though I'm not going to show you how to measure everything in that data file. Again, I just want to show you a couple things about that data file. So open. Do I want to save the changes? Sure. So this one is also in my downloads. This one starts with EEG, so we got to go down to the E's. There it is right there. EEG Alpha Demo Mat Lesson 3, open. And here's that one. And so I already have this one set up pretty similarly to the other. The channel 1 standard deviation measure right there. And then I have 40 measurements over here. I'll change this one to standard deviation again. Where was that? There it is. It doesn't really matter because I'm just using this one anyway, but those will all say the same thing. They'll all measure the amplitude, that's the standard deviation, for the selected portion of channel 40. So a couple things about this one. This is the other data file. This is the one, the video that you saw was the other data file. This is a data file that I recorded even before the other one. But it's similarly structured. A couple differences though. So this is the runtime at the beginning is shorter. So within like a second or two, that's when I opened so my eyes were closed here. And then very soon after I started recording the EEG, that's when I pressed the first marker was pressed, which is when the eyes were opened. So this eyes open trial is right here. Standard deviation, the amplitude is around 3.157 or so for that eyes open. For the eyes closed, it was 4.0576 for the eyes open again, 2.829 or so. And then finally, for the last eyes closed trial, it is the amplitude was 3.48. 3.48 for this last one approximately. So yeah, when you're writing in these decimal places into Excel, go to at least the hundreds place. Thousands place might be a little bit better, but at least the hundreds place should be fine. So I ended up showing you how to record to measure the amplitude for this one too. What I really wanted to show you though is make sure that you know that trial 1 here starts at around the 2 or 3 second mark right there. That's the first trial. This is trial 2, trial 3, trial 4, and then the stuff at the end, you can just ignore that. This is an eyes open trial, eyes closed trial, eyes open trial, eyes closed trial. So that's the other data file. So I've already showed you the Excel spreadsheet. You will fill this in for both participants, even though I'm both participants. And then the means of the other participant will appear here. Once you type them in here, they'll automatically be calculated because of the Excel formulas that appear in these cells. And then this will be what you copy and paste into the Google Sheet. So I should show you that Google Sheet. The Google Sheet is right here. Some groups from my morning session have already done it. So this Google Sheet is different than the others because we only have 2 participants right here. They're both me. Usually we'd have like 30, but we only have 2. So one thing, we won't be performing statistical analysis because our sample size is too small. We might be recording, calculating Cronbach's alpha for a part 2 of this lab. I want to see how the data look before I commit to that. That is calculating inter-rater or inter-judge reliability. So we only have 2 participants because you guys are not the participants this time. I was the participant. We only have 2 of me, 2 data files for me. What we do have are a bunch of judges, a bunch of raters. And one thing that we could potentially do is see are the ratings consistent? Are you guys being successful at getting consistent? Are the different judges getting basically the same amplitude measurements for each of these trials? And so what you'll need to do when you're copy and pasting, you'll just copy and paste those 4 means. These are the 2 participants. You copy and paste those 4 means, or these 4 means right here. You copy them, go to the Google Sheet, and paste them at one of the open slots. So right now, I don't think there's 36 judges, which means if you guys all worked alone, every single person who was enrolled in this class from the beginning, there would be a space somewhere. We don't have to use all of these spaces. That's just the maximum amount of spaces we could possibly use. Would be one for each student in the class, where there's from the original enrollment numbers for this class. Basically, you need to find one of the open judge spot spaces and then copy and paste your 4 means into that space right there. And that is it for this. Just make sure you don't overwrite someone's who is already using that space. So make sure you find an open spot. Okay, so one more thing about this lab before I stop recording here is I do want to I've showed you literally how to calculate the amplitudes for each of the trials. And so I want to make sure that no one's just taking my numbers and, just physically typing in the numbers that I calculated. So to demonstrate that you were successfully able to calculate the alpha amplitude measurements by yourself, I'm going to ask you to take a screenshot. So I'll show you where the instructions for that are. So if you go to labs, the bottom, lab9. This is where you can download the Excel sheet for today. You're going to download this, type in the 8 amplitudes that you calculate, and then the 4 means will be calculated automatically for you into this Excel sheet. And also the slides that I referred to at the beginning, those are available here if you want them, including the link to the video where I recorded myself being a participant in this data collection. The instructions are down here though, so you'll be taking 2 screenshots after you've made the measurements, 1 screenshot for each data file. So what you'll be doing is you'll highlight this, this is trial 1 for participant EEG alpha demo math lesson 3. So you would want to make sure that I can see the portion that's highlighted, and the thing that you're gonna have to do this for each of the participants. You're gonna have to highlight the first trial, and then I need to see the amplitude measurement, that is the standard deviation measurement for that trial for the alpha channel, which is what I have right here. So this is 3.166, 3.1661, we'll say, for the E. So I would write that here, 3.1661. I think I said that right. Yeah, that's right. And you'll write it right here. And so you would take the screenshot. I'll just do it even though I don't need to. I just took a screenshot. And then this would be, you could crop it. So I don't need all this stuff at the bottom, but you could crop it. What I need to see is the portion that you have. I want to see the full, all of the waves, though I actually don't need to see. I need to see all of the alpha wave. And I need to see the portion that you have highlighted. So all of the alpha wave. And in particular, I need to see the portion that you have highlighted. It needs to be the first trial, which is an eyes open trial. And then I also need to be able to see the amplitude that was measured for the portion that you're highlighting in the alpha channel right there. And I'm going to be looking, is the number that appears right here in the screenshot, does it match the number that appears right here in the group, in the Excel file for that group? You'll have to do one for this participant, and I didn't do it when I did it earlier, but I should have. You will also take a screenshot when you're calculating this measurement. So for each participant, and it says it down here, please include a screenshot of each data file with the first eyes open trial selected, that is, means highlighted, so that I can see the alpha amplitude measurement for that trial at the top of the screenshot in the channel 40 box using standard deviation, that is amplitude. The number that appears in that box, that standard deviation, that is the amplitude measurement, should match what you type into Excel for that trial. So the first trial for each participant is for me, it's in column C, and I'll be looking to see, you'll be turning in 2 screenshots, 1 for each participant. I'll be looking to see that the screenshot amplitude matches this, and I'll also be making sure for the other screenshot that the amplitude which shows matches this one right here. So this is verifying that you actually did perform these measurements yourself, and that they match what you type in to Excel. And then this is called part 1. You'll be turning it in right here. The things I'll be looking for, just to kind of summarize, because I'm basically done. I'll be making sure that you have all of the measurements, and all 8 of these will be filled out with numbers that are reasonable. These numbers should automatically be filled with, these cells should automatically be filled with the numbers. These are the means that should be calculated based on the formulas that I already calculated for you. And then the 2 screenshots, just go ahead and copy and paste them down here. Just make it so that it's very easy to see. Don't put them way down there where I'm gonna have to scroll for a long time. Put the screenshots so that I can see them right when I open up your Excel document. And then I'll be making sure, once again, that the amplitudes on the screenshot match this stuff right here. Also make sure that if you're working in group, well, either way, make sure that your names are highly visible. Either put them somewhere where it's very obvious on this sheet, or if you want, you can put them on the other sheet right here, somewhere in the upper left-hand corner. I don't care. Either way, we'll see them either on this sheet by themselves or somewhere on this sheet where it's very salient. Put all of the names of your group members. And I think that's about it. Let me know if there are any questions. I will be happy to help. I will post this, of course, on YouTube.